The world of automation is undergoing a paradigm shift. This changes everything. Welcome to Universal Automation. The world of plug-and-produce software components, making complex things simple and reliable. Think of it as the dawn of an industrial automation app store. The IEC 61499 standard is the key to portability and interoperability. UniversalAutomation.org is the community managing an industrial-grade reference implementation of 61499. Because no one vendor or company or person can bring about transformation on their own. Universal Automation allows us to use software and hardware in a whole new way to create portable applications and innovative architectures. For the first time, IT and OT engineers can easily work together, combining real-time with right-time to create cost-effective and innovative ways to address complex use cases, like predictive maintenance, production optimization, and virtual commissioning. But how does Universal Automation really impact you? Vendors can use the Universal Automation reference implementation to bring IEC 61499 offers to market fast. That means new software revenues, new business models, and new customers. Universal Automation frees industrial enterprises to integrate best-of-breed components and proven in-use software. You can realize step-change advancements in efficiency, flexibility, and modularity with agile operational models. It's time for us to release the full potential of the fourth industrial revolution. Be a part of the community delivering the solution. Join universalautomation.org.
Hello, good morning, good afternoon, everyone, and welcome to this new session of UAO Goes Live. I'm happy to welcome you today in the part 2 of our AI services series. So we started last month with the Professor Viatkin explaining us about the new advancement done in AI together with 61499. They were using the startup FlexBridge to show us that. And this week we are going not so far to the LTU University with Midun to go again and go a bit further about AI services. So Midun, please join me on the stage.
Hi,
Midun.
Greg.
How are you doing?
Hi, Greg. Yeah, I'm good. How are you?
Yeah, very good. I'm happy to welcome you on the stage of UAO Goes Live. So can you please tell us a bit more about you?
Yeah, thank you so much. My name is Midun Xavier. I'm a PhD student from UAO University of Technology, Sweden, and I do research on developing AI agents for industrial control system. Yeah,
AI,
that's it.
a very trendy topic, actually. So that's why we made 2 parts about that, because that was quite interesting, and we have seen as well that the number of viewers quite exploded when we mentioned that the next topic would be AI. So please show us a bit more what you have for, maybe a bit about university and so on.
Yeah. UAO University of Technology is located in the north part of the Sweden. Maybe as you can see here, is it near to the Arctic Circle? And we do research on the 61499 control system. So most of the advancements in the AI and related to the most technological aspects, which we are covering over here. So that's what we do. And that's all about the university, but I will be explaining.
May I interrupt you? Because I think we don't see your slides.
Yeah, okay. Is it?
Yeah, it's moving.
Is it okay
Thank
now?
you. Yes.
Yeah, okay. So I will start with that. Yeah, so today I would like to discuss about the industrial AI agents, that is AI agents for the machines. This session will be divided into 3 parts. The first part will be showing the recorded demo video of the real system, which is in our lab, how the AI agent can interact with that machine. And in the second phase, we'll be showing a live demo with the simulation, how the AI agent can incorporate with that and interact with this digital twin. And finally, I will be introducing an agentic platform so that everybody can build their own AI agent for their machine. So let's move on here. So as I discussed, the Luleå University of Technology, it's located in the north part of the Sweden, and you can see the Arctic Circle. It's near to that. It's located. Okay, and its LTV is known for Nortec Center for the IEC 64099. So this is our lab. That is Ice Cube Lab. It's in a factory in a room. There you can see many systems which resides in our lab. One of the system which resides in our lab is called the processing station. And I just want to describe about this processing station because soon we are going to watch a recorded demo video of how AI agent can interact with this machine. So this processing station is consist of three mechatronic components. And the first component is known as the rotating table, and it has 6 positions. And a complete cycle is achieved when the table rotates 6 times. And the other component is the tester component, and it is located in the second position, and it is used to test whether the workpiece has hole in it or not. And the third component is the drill component, and we know that what the drilling station does, it drills the workpiece, and it is kept adjacent to the tester component. So here is the processing station which is there in our lab. So let me show the video of how it can be how it's interacting with the system. Okay, so I hope you can see. So this is the AI agent interface. So through this AI agent interface, we can communicate with the processing station with the natural language. So initially, I will be like uh, uh, giving a command like I have positioned a workpiece on the position 1, and just want to drill the workpiece and bring back the workpiece to the position 4. So what the AI agent does means it knows that this is a processing station and what it can do, and it plans and describes the things which is needed to do for this particular task. So it explains the each step what to do. And here we can see it rotates to the position 2 because in order to place this workpiece on the uh, tester component and need to detect the hole using the hole detect skill. That is action needs to be done. And if there is a hole detected by the tester component, then we don't need to drill it, so we can skip and bring back the workpiece to the position which we asked for. Otherwise we need to do the drilling. So that's what it plans, and after the planning it execute the skill one by one. The action, the first one, it is rotates to the tester component and check for whether it has a hole in it or not, and then it moves to the drilling station. It identifies that there is no hole, so it can start drilling when it's under the drill. And now it will move to the position 3. That means it under the drill, and you can see the drill which is moves inside the workpiece to drill it, and it brings back the workpiece to the position which we are asked for. So that's what we can see in the first scenario. Okay, so that's done. So now let's see the second one. uh, yeah. Okay, in the second scenario, I have just asked, I have placed the workpiece on position 1, but I need to test the workpiece twice in order to check whether it has a hole in it or not. Just a random one. So we can see that it plans that what to do. That means it needs to rotate to the station where the tester is located, and it needs to test it. But not only once, it needs to test it twice because that's what we uh, set set to the AI agent. So it does the checking twice in order to identify whether it has a hole in it or not. So it does that process, and after that it identifies that there is no hole in it, and so this task is completed, and it's bringing back the workpiece to the positions which we told to the AI agent. So AI agent communicates with this machine and brings back the workpiece to the desired position. Okay, so that's done. And so let's see how the AI agent interacts with this machine. What is the solution behind it? So here we are using 64099 control system, and this standard helps us to focus on modular event-driven control system, and it enables dynamic reconfiguration of processes. So processing station consists of mechatronic components, and each mechatronic component has a PLC, and the distributed control system is designed using 64099 standard. And here we are using a skill-based model design pattern. That means we need to understand what is skill. Each skill represents a defined function. That can be drilling, welding, milling, or maybe detecting a hole. That can be a skill for associated with a component. And these skills are known to the AI model, that is a LLM, which we are using here. And what it does, whenever we ask for the new task, AI identifies and sequences necessary actions for the new task. And it also automates the process planning for different tasks, which we are telling to the AI agent. The benefits of this approach is that we can customize your own agent to interact with the machine. And also we can develop, test, and new production sequences using AI. So yeah, so let's dive deep into more technical terms, like what is 64099 skill building block. So I will give a first what is a skill. That formal description definition for the skill is that it's a skill represents a modular reusable function or an operation that a control system can perform. Each skill typically tied to a specific piece of equipment or a resource, such as robot, sensor, or actuator, and is designed to execute particular task. That means drilling, which is associated to a drilling station, and that can be considered as a skill. And here we can see a skill function block, which is a 64099 function block. And this function block is to, it's what it is means, it has a ISA 88 standard state machine inside it. It helps to develop a skill. Just drag and drop this skill function block to our control system application and connect the necessary things to the control function. The control function can be drilling or detecting a hole skill or something like that. And yeah, so this is our processing station, and we have already a 64099 control system. What we need to do is like drag and drop the skill function block and connect to the test skill or hold detect skill or rotate skill, something like that. So it can do the necessary function. So here the processing station has three components, and there is three skills, and each component is associated with their own skill. And it is possible to have several skills associated to a one component itself, but here we are using only three, and each, and here we can see the table component is it's associated with the rotate skill. And what it means like rotate the table to one position clockwise. That's the definition. And the hold it at skill, it identifies whether the workpiece has a hole in it or not. And finally the drill skill, which drills the workpiece. So this is how it's designed, and how we are going to execute this skill, because now we have the control system and also the skills associated, it's there. So if we need to execute the skill to drill it or something like that, how to do it? Of course, there is a HMI is there to execute the skill by start and stop buttons. It's associated with that because we are using the skill function block. It has an HMI inbuilt for that to connect it with the respective skill. And it is also possible to execute the skills via OPC UA. That means using the OPC UA client, we can use the OPC UA variables in order to execute the skills. And HTTP is not enabled yet, but it is possible to integrate the HTTP protocol as well, so that we can we can execute the small actions on the machines remotely. So how it works, it's what in an AI works in the perspective, the whole thing is given here. That means we have a processing station, skills associated with that, and each skill can be uh, executed via OPC UA. So this information is known to the LLM, so that it's possible that the LLM knows that what are the skills available and how to execute the skills using OPC UA. So if an user asks for something to do it, drill the workpiece, something like that, and what this LLM does means it searches for the what are the skills available to this system and identifies what are the skills which is needed to execute this skill, this task, and it formulates the plan and execute the skills one by one. So here we can see the 649 AI agent can be used in manufacturing marketplace. Means this AI agent has a skills which we associated with that. We don't know it, how it works, and we know that how it communicates with the machine, this AI agent using OPC UA. So the main thing is like this AI agent can reason. This is a React agent. That means it can reason and act based on that. That means consider a situation like which we have already discussed for the processing station. We need to drill the workpiece. Then it searches for the skills available. Then it identifies that there is a skill to detect the hole. So LLM identifies that this skill can be used in order to identify that whether the workpiece has a hole in it or not. If there is a hole, then it no need to drill it, and if there is no hole, then it can pass to the drilling station to drill it. How it is achieved, because it plans everything and execute one skill by skill, but there is a response we can get it from the uh, tester component or any component after doing a particular action. So if the tester component doing an testing thing, whether it has a hole in it or not, and it gives the feedback to the AI agent, so that AI agent can get the feedback for each action, and according to that it can dynamically respond to a recipe which we are asked to get it. But it's very strange to execute these things on the real system. Of course it's possible to do it with the digital twin or simulation, won't be harming the any problem. But if it's in the real system, we can also introduce human in the loop concept. That means before executing each action on the machine, the AI agent will ask the user that whether should I execute this action on the machine or not. If the user says that okay, execute it, yes, if it's replaced with yes, then it executes it, the action. Otherwise it is otherwise it won't execute it. So we can use this for the uh, initial phase, how it reacts, and with the safe implementation can be done like that. So now we will move on to the kind of a one digital twin, and it's kind of a live demo which we are trying to execute here. And before we are going to do, we are experimenting with the distributing station. That means AI agent now interacts with this machine that is called the distributing station. And this distributing station is consist of a two component, that is a rotating arm and a magazine. The rotating arm has four skills, that is go to left skill. Arm can go to the left position, left area, or arm can go to the right side. So there are two skills, and other two skills are pick the workpiece, that can be another skill, and place the workpiece is the another skill. And the magazine has two skill. One is push skill, which is used to push the workpiece to the rotating arm end. And the second skill is called load skill. Whenever the magazine is empty, using the load skill, we can load the workpieces. So let's see a demo. So here is the station, distributing station. So skills via HMI. So I have moved the rotating arm to the left side. Now I can also move to the right side. So this is straightforward. So I can interact these skills using HMI, but it's also possible to execute via OPC UA. Now we can see I will place uh, the AA agent interface, which is configured over here. Yeah, so I will place it bit short. Yeah, okay. Yeah. So now you can see here this AA agent. I think it's possible to see it. Okay. Now I will ask first, what are the skills available to you? So I can also get an understanding that what are the skills available to the system. So it explains that these are all the skills available to the distributing station. Okay, so I just want to execute one action, that is a simple action which I take, move the arm to the left side or something like that. So what it does, it doesn't need to plan anything or something like that, because it's a single action. It's straightforward. Nothing, no need to think much for the LLM because it's straightforward, just one action. Once it's moved to the left side, we will get a response from the action that it's moved to left. So it says that it's moved to the left side. Likewise, we can also move to the right side. That is also a simple, straightforward step that it can move to the right side. And now we are composing these skills together in order to do a bigger task. That means which is one query which I have used. It's here. That is pick the workpiece from the magazine and drop the WP, the workpiece on the right side of the rotating arm. So that means it needs to some of the things. It needs to do some actions. So let's see whether it works or not. So it plans what it needs to do. Push the workpiece from the magazine. First thing needs to do the push the workpiece, and we need to move the rotating arm to the left side. That is the second action, and we need to pick the workpiece. That is the third action, and we need to move back this workpiece to the other end, and that's what we need to do it. So let's see whether it's start to execute or not. It's keep on running. Let me check. Yeah. Yeah, it's a bit delayed, this process, because of it's getting stuck because of the yeah, maybe I will just restart it and see whether it's possible to run it. Yeah, okay. Let me check once again the skills are okay and working. All the variables are okay. Yeah, maybe I need to restart the HMI once again. Sometimes it has the issue with uh, doing the things all together, but most of the time it used to work. Yeah, maybe sometimes it happens. So that's how it's supposed to do. It needs to try it and do the task one at a time, and according to the feedback, it needs to try it. So maybe I hope the echo structure has been had a issue. I think yeah, something is building the project. So uh, it is maybe it's due to the problem of the echo structure. It's getting stuck. I need to restart the echo structure automation application once again and needs to run it. Yeah, but it's okay. But I think like that. What I'm going to supposed to do, everybody got it what I'm trying to do. Okay, so let's move back to the presentation once again. So here we can see I here now it's in the last phase. I am going to introduce a agentic framework so that everybody here in the uh, audience can create their own AI agent for their machine. That's what we are going to discuss in this phase. So definitely for the machine, if it needs to communicate with the AI agent, which we are talking about, there should be a communication protocol. That can be OPC UA, MQTT, or HTTP, anything. But some protocol needs to be there. But here we are using OPC UA because it's commonly used. But it's not only for the machines. We can also use the same thing for the digital twin or simulation. So define the OPC sensor and the actuator variable for your machine, and configure the AI agent with the OPC variables and methods. And test your AI agent with various workflows and deploy your AI agent for the machine. And if you deploy it, then it's like every machine will be having now an AI agent for that. And these AI agents will work together uh, using an agent orchestrator, and we can build a multi-agent system. So here is the how this AI agent needs to be configured and how it works. So I have already shown the distributing station, and here is just need to uh, no need to think about any other complex things. Just need to represent your OPCUA variables. That means sensors and actuators. So this one has the left some sensors, like whether it's a rotating arm on the right side or left side. So we have a sensor, and to move it, we have an actuator. So those information should be available when the OPCUA server is running. So our AI agent just connect with that and integrate all your variables, and now play with the machine using the just interact with the machine using the commands which we can directly give using the natural language. So maybe I will show the platform so that everybody can use it. So here is the platform. This is a AI agent for machines. I have set up a OPCA server on the cloud for the testing purpose, so that here we can just connect the button. So it tries to get all the variables, OPCA variables or methods, which is available. So here we can see the temperature, pressure, the motor speed. The motor state is to turn on the motor, and the valve position is to turn on the valve or not. These are two actuators, and the temperature, pressure, and the motor speed are the sensor values. So these are the available values which we can see over here. What we need to do is like just add this variable to the environment. So once it added, here we can see the temperature variable is added to the agent environment, and we can describe, if we didn't like the description over here, which is the description which is already kept by the OPCA server, which when we designed, we can type something or add something, and after that just integrate it. So this will be integrated to the system. And here we can see the system description that what the agent should do. So this is an industrial automation system controlled by OPC server, and the system consists of a sensor, monitor, something which the AI agent needs to do. Just give the system prompt. This is up to us. We can remove it or add it something according to our need. Yeah. So what are the variables which you require? Just integrate it. So we have integrated this one. We have but it's up to us that what are the functions and what all the functions or the sensor values needs to be integrated. And here, yeah, we can also we can integrate over here. Yeah, then the while position. This is the final one. Let me integrate this one as well. Yeah, now it's integrated everything. Now we know that these are all the PCA variables of the system, and what we need to do is like test the agent. So now we can test the agent, like yeah, okay. Now we have the configuration and everything. We can download the configuration. Deploy agent, it's not available yet, but it will be coming soon. So we can say that uh, what what is the system status or something like that. So I think for the system status, it needs to, yeah, it will get all the sensor values. This is the case. Our motor is off. So let me try that. Turn on the motor. Simple command. So it's trying to turn on the motor, and the motor has turned on successfully. We can save this kind of task if we are asked, and we can save this workflow in the future. So that's the thing. And we can verify that whether the motor has turned on by refreshing the variable. So this motor state 0 will be turning to 1. Yeah, that starts to run, and the motor speed is now like 205. Likewise, we can turn it off or something, turn on the valve or something like that, turn off the motor. Likewise, we can play around, or we can also make use of that different uh, task connect together to create workflows. Only that workflows can be saved and used in the later stage. So now we can see it's turned off. So maybe let me check. Yeah, it's turned off, and uh, hopefully the motor speed will be reduced soon. So, but most of you guys will be working on this OPCA server on locally. So this website uh, doesn't allow now to connect your local host directly, but it's possible that to connect your TCP port via tunneling using ngrok or something like that, which we can use. Otherwise, if it's already in the cloud, do you have an OPCA server, then it's completely fine. You can just give the connection string over here and connect it, so it shows the variables which is need to connect it, and you can configure it and create your agent and play with the agent, like to do some task. So that's how it's does. But definitely it needs to be it needs to be public IP address so that we can access it. Otherwise, need to tunnel it using ngrok. Yeah, so that's how it works. So let's see the steps once again. Yeah, use your connection string, connect it. There will be available variables or methods. We can see it. Add to the environment. Develop your own system prompt to it. and integrate it. And finally, if it's okay with the testing, which we are introducing soon for the most complex testing and evaluating these agents. And once it's completed, it can be deployed to the cloud or somewhere so that you can interact with your machine using the agentic interface. So this is the platform. So please customize your own agents using this one, and please scan this QR code and just explore how it works and give us the feedback that what's to improve. So that's it from my end. Thank you so much.
Thank you, Midun. Thank you. Let's go back to the stage. Yeah. Well, I haven't seen any questions so far. So let me ask you. You said that your AI agent is based on LLM, and this is where you do your prompt instructions to get your skills, let's say, programmed. And which LLM tool are you using behind, let's say, to pop the hood a bit? And did you make some comparison between different LLM tools to try to see what is working best and so on?
Yeah, for the time being, we have tested a few of them. The GPT LLM 4.0, which we are using right now, 4.0 mini, that's fine. Some other, the Anthropic Claude, which is not seems to be up to the mark with comparison with the GPT for to reason this task and doing the things. And and also local LLMs also tried, but it's a bit it's not even up to the mark, and it's getting a lot of time to execute it. So that's the one of the other reason. And the main thing is like not all the LLMs are won't be able to do it for the time being, but hopefully it will be like can be used with the local LLMs as well. That's what we are aiming for, so everybody can build their own agents locally and interact with that.
And let's say that okay, you go with one of the LLM. How do you do your feedback to the AI tool to say okay, this is more this kind of way I want to program my skills, or how is that done? Do you feedback directly with the function block, or do you do like a description of the block, like the way you want it to actually be programmed and sent back to the tool, or how is that working?
For the initial testing phase, now it's not integrated the feedback, but the feedback will be given like whether what we are doing, it's like for as a reward to the LLM, that if it's doing the right thing, then we will be giving the feedback. Then after that we will if it's not the right thing which we are asked to do, then we will be giving the penalties for the LLM. So that in that structured way, we are trying to build the kind of a system, like what are the uh, good steps which we have done. Then we will be storing that as a knowledge base, so that LLM will be having the understanding of what are the tasks which gives the most rewards. So based on that feedback kind of a system, while we are testing and also evaluating what are the steps it can do for the safe operation of these machines on the shop floor or something, that needs to be integrated. But definitely that could be the part needs to be explored more to make it this AI agent safe in the industrial control system.
Yes. Let me put back the QR code that you gave us, just to give people enough time to scan it and to try using the AI agent and make their feedback to you. I think that's quite important to make your, let's say, your research complete. what are we missing here? What is the next question that you'll try to tackle with these AI agents?
The next thing it's like first we need to deploy this one. After the testing, definitely we need to
Mhm.
deploy the agent for the machine, uh, for everybody. For me, it's okay to develop it by coding and creating the agent, but it's difficult for us, the industrial persons, to code it and make it right working and deploying, and that's a bit difficult. So I need to make sure that they can test it, and once they are okay, they can make it this deploy on the cloud or on their local premises. Once we have that, we will be having several AI agents for them, because maybe most of them will be having the different, like 3 or 4 agents will be there. Then next task will be like how to communicate these agents work together for the shop floor or something. So that
Okay.
means there will be a agent orchestrator that will be giving the task to each agent, and there will be a handoffs between the agents, like one will be doing, after that it will be giving the task to the other one, so it will be managed by the top level agent. This is the feature in the GPT 2 days ago they have released. So I think now it's much more easier for us to integrate to this our environment as well.
Okay, great. Thank you. Thank you. So I still don't see many questions from the crowd. So I would suggest that if you have any question, just drop it in the comment of this video, and we'll be happy to answer your question later. Midun, thank you for making it this afternoon. Again, how to contact you, your name, and your email address. So please feel free, if you have any other question or you need another explanation and so on, to contact Midun for that. The video stays here and you can watch it again as much as you want. QR codes, we gave it to you so you can use the AI agent as soon as possible, which is now. Oh, I see that Chiu-chan had a question. So one question: how could the AI agent resolve the issue of uncertainty of response for LLM?
How?
For example, the skill expected the AI agent is motor on, but the LLM response was motor start, or some
uh,
cases in this way. Yeah.
Yeah, definitely. This LLM agents I have trained based on the basic knowledge of language. So it has the capability that to differentiate between this one motor on or motor start. But if we need to specify what to do for the motor on or motor state different, make it different, but then we need to try it on, we need to configure it on the AI agents that what to do for each
Mhm.
particular thing. So it's up to us to decide that how much deeper which we need to try it. Otherwise otherwise it might uh, make it confused. That's why we need to test it that's up to us to make it more reliable uh, by giving more information to the agent that how it needs to perform.
Great answer. Jochen, thank you for your question. So I think that was the last one to show. So Midun, thank you again.
Yeah, thank you
I
so much.
wish all of the viewers a very good day, and then talk to you soon and see you. Bye bye.
Yeah, bye bye.